Students, so I welcome you all back to a new video. So today we'll be discussing about Reimer Tiemann reaction, which is quite important, right? So this is one of the named reaction which we'll be discussing. Fine. So firstly, let us see the general reaction. What happens in this reaction? We have a phenol. On this phenol, when I treat this compound firstly with chloroform and then put in some base, what happens is we get a compound which looks something of this sort. What is this? This is my salicyl aldehyde. Okay. Yes. Now let us see the mechanism behind this reaction. So mechanism is what we will be seeing. Fine. So firstly, what happens in this mechanism? I have chloroform which will be existing in this form. Can I write it in this form? Yes. Now in this chloroform, can we see there is a base also in the reaction? So base will go about abstracting this H plus and the bond will cleave in this fashion. So what will I be getting? Carbon pairing minus charge, carbanion is going to get generated and 3 chlorines are remaining. Now this carbanion will shift back the electron density here and chlorine leaves the reaction. Fine. After chlorine leaving the reaction, can I tell I'll have CCl2 which will be formed and radical will be generated. This is called as dichlorocarbene. Okay. This will be acting as a attacking species in which reaction? In Reimer Tiemann reaction. Clear? Yes. Let us see how does the attack take place. Okay. So take a phenol, and you know in phenol, when I treat this compound with a base NaOH, ONA minus will go and sit at this position and form sodium phenoxide. From sodium phenoxide, I can take up phenoxide ion separately, and this phenoxide ion is in resonance, right? So can I tell? I'll just show this part in this format so that things are very crystal clear. Minus can shift the electron density down towards the next carbon, and this next carbon will shift the electron density towards the ortho position. So if it happens, can I tell that minus charge or carbanion is generated at which position? At ortho position with respect to this carbonyl group, right? Now this CCl2 will come into this reaction, CCl2, right? This is my dichlorocarbene. Now this carbanion will go and attack this CCl2 radical and form this as an intermediate. Is it correct? CCl2. Now you know carbon cannot have 3 bonds, so minus charge will be here, right? And you also know that this has hydrogen also, right? What has hydrogen? This carbonyl compound having, with respect to this carbonyl compound, this alpha carbon is having one hydrogen also. This hydrogen will try to tautomerize, and this bond is going to break down, because of which keto form is going to get converted into the enol form, correct? So what happens later after the formation? I'll have OH here. After tautomerization, enol has been formed, as you can see, and this will be having CCl2 minus charge, correct? Now this compound minus wants protons in life, and you can see acidic hydrogen is here, so he will go and attack this acidic hydrogen. So what is going to get generated? I'll have phenoxide ion here, and here I'll have CHCl2, correct? Now after this, what am I going to do? I'm going to carry out the reaction in presence of base. What is going to happen? SN2 reaction is going to happen, and this OH minus ions are going to replace this chlorines, right? So what is going to happen? Once when I put KOH, one of my CHCl2 ka Cl will become OH, correct? And another time when I put in the same, so I'll write it here. Okay, so when I put it here, what is going to happen here? I will have O minus CHOH OH. How did I get this? When I put in 1 more mole of KOH in presence of SN2. Okay, I mean SN2 is going to happen, and I'll get this. And you know, because of oxygen bearing lone pairs, At one carbon I cannot have two OH stable. So what am I going to remove? I am going to remove water. So after removal of water minus H2O, what am I going to get? I am going to get a phenoxide ion is still prevalent here, and here I'll have C double bond OH. Now this phenoxide ion will take up H plus from the reaction medium, and what will it form? It will form my desired product, which is salicyl aldehyde. So this is pretty much about the mechanism for formation of salicyl aldehyde. Yes, so this is pretty much about our Reimer Tiemann reaction. I'll see you in the next video. Thank you so much, guys.